Okay, good morning, everyone. My name is Sung Jun An. As Professor Chi already introduced me, I'm currently work at the Hong Yu University. Today, the title of my seminar will be Application of Knowledge Graphs to Represent Construction Standard Information, focusing on research cases. As Professor Z mentioned, it was only recently that Professor Z and myself realized that we have some common interest in research, and that was related to the research topic theme 2 from your slides, which is about the digital transformation of the construction guidelines and construction standard information. As you will see, the difference between the Professor Z's focus and my research area is just the type of standard information, because there are lots of standards, as you all know. There are lots of information and the standard information in construction, because the construction industry is entirely very much driven by standards, as we all know. My research focus is largely in the construction safety management sector or area. In safety management, standard is golden rules. So there is, no matter what country you look at, Australia, US, or Canada, each country, including Korea, they have their own standards regarding how to manage safety. So I'll introduce more about my research in the later slides, but it's a great honor and privilege to be here, to have an opportunity to share my recent research efforts. So this is the outline of my presentation today. Firstly, because many of you saw me first time today, so I'll introduce myself a little bit, and then I'll take just a couple minutes to introduce the general background of my research, and then my main purpose or objective in this seminar is dot point 3 and 4, which is basically sharing and introducing my current research effort, which are largely aligned with each other. So the first part will be about the modeling construction safety guidelines in knowledge graph, and the second part is just briefly modeling BIM guidelines in knowledge graph. As you can see here, the repeated words is modeling of some kind of guidelines. The first type of guideline that I will introduce you about is the safety guidelines, and then the second element is about BIM guidelines. BIM has been introduced in the construction industry for about 15 years now. And then it's only recently government, such as Korean government, published all very detailed BIM guidelines regarding what designers should do, what constructors should do, what the project owner should do in regards of how to use BIM. So it's lots of guidelines. Sort of like declarative statement regarding, okay, designer should submit designs in this format as such. And then I'll just have a couple slides to share my vision regarding how this type of research will move ahead. Okay, so that's the outline of my presentation. Firstly, personal background and affiliations. So this was supposed to be an animation, but I had to convert it to PDF because of some font errors and issues. But as you can see, the point that I'm trying to make is I've been moving around a lot. I started my journey at Seoul National University, where I studied for my bachelor's degree and a master's degree. I was trained as a civil engineer at the beginning because I was my bachelor's degree is in civil engineering, and then I moved to architectural engineering department for my master's study. Just only the reason was there was no construction management or informatics lab in Seoul National University at the time when I was graduating in 2008. So for some reason I was really fascinated and interested by that subject area, so I wanted to study that, and I realized that not in civil engineering department, but in architecture engineering department, there is a great research lab, so I joined that. And then after finishing the master's degree program, and I moved to United States, at University of Michigan, where I studied for my PhD. And after that, I moved again to Canada for my postdoctoral fellowship. University of Alberta has the largest construction management program in Canada, as you might know. And then I move again to another continent, Australia, down there. So that was the University of South Australia was the place where I found my first sort of a permanent job as a faculty member. So I was there for 5 years. And then I came back to Korea after this 11 years of journey overseas, studying and training myself, for some positions like, a professorship in Hongik University now. So yeah, so I'm currently at Hongik University. In 2021, when I was joining Hongik University, I had to think about what has to be the name of my laboratory, my research group, and then I decided to make it as a database construction management. So the most brief way to introduce what I do or what we do in my research group is how to make construction management tasks and all operations largely just all based in data. So we use a lot of data science technique, and we use a lot of try to use a lot of AI-based techniques to automate and digitalize construction management works, such as scheduling, cost management, design management, and construction project overseeing or controlling, coordination, all that kind of efforts in construction industry. I still have adjunct senior research fellowship at my previous university, University of South Australia, and also serve the American Society of Civil Engineers as an editorial board member in JCEM and JME, both of which are one of the most reputable journals in my field. So I think that's enough about myself. The next few slides, I'll talk about the general research background. The first key terminology that I would like to start with is the knowledge graphs. So what is a knowledge graph? So some of you might have heard about it, and some of you have never heard about it. Knowledge graph is a database, and the most famous database is all relational database. So like whenever you think about database, so what kind of a format of the data comes into your mind? A lot of rows and a lot of columns. So something like Excel spreadsheet. That's the look of data that might come into your mind when you hear the word database. Knowledge graph is another type of database. It's all very much graph that looks like this. So this is what's database? Database is a container to store and process and manage data. So instead of all this structured rows and columns format of data, what if we use some more flexible form of graph type of data? So it is not actually something very, very new. The graph database has been around in computer science world for more than 20 years. But what's the really the main characteristic of it? The information can be contained largely in nodes. You can see it as an object. So probably many of you are familiar with like object-oriented modeling. So you can see this like each node can contain some sort of information. So here I'm showing an example of personal information showing the ID and name and age. And then all these links can contain information about the relationship between them. So for example, the label tells us a lot. Label is knows. So this person Alice knows Bob, right? And then and then the label is member of. So actually this is a name class, and then this is a group class. So the relationship between these two is that Alice belongs to this particular group. So it's all about relationship. So the easiest way to think about graph knowledge is the knowledge database is a sort of a form of a database that is the best and most suitable for containing all the information of your friend relationship. You may use a relational database to contain information about who's friends of whom, but this is the most intuitive form of database to contain that type of information all about relationship. So yeah, this slide shows some the advantages of knowledge graphs. So graph data the graph database will look like this on the right hand side, and the relational database is all like rows and columns. So to contain that kind of information about the relation, graph database is very intuitive. So all you need to do, just for example, like to represent the social relationship, I'll have a node to represent myself, and then I'll have another node to represent, like, for example, another person. I'll say, okay, I know this person, or I'm friend of this person. So that kind of thing is easily and very intuitive modeled. But in the relational database, it might be possible, but it requires a lot of rows and columns. And then these separate tables has to be joined, and then lots of computation has to occur to figure out who's friends of whom. So the most well-known advantage of knowledge graph is efficient at managing complex relationships and a highly flexible schema. So let's just suppose like graph database originally has all information about friendship. And then I want you to add some more information about the car ownership in this knowledge graph. All I need to do is just create another link or another class of link says own. And then I just add another node calls like, a specific, brand of manufacturer and then a specific car name. So it's very flexible. Whenever you want to add some new type of information, you don't really have to change the whole structure of the relational database, but when you want to do that, you have to actually update the whole structure of the relational database. Why? Because it's not a very flexible structure. So you have to change all the design of the rows and columns and all the rules to join different information from different separate sheets. So that's the advantage of a knowledge graph. And also another big background motivating me studying in this research is the largely, really innovating and industry-changing NLP-based technology. I'm sure that all of you have used the ChatGPT. I use ChatGPT nearly every day for work, not just for fun. And then, as you can see here, like ChatGPT's subscribers has increased like faster than any other platforms. And then I just searched for some news articles like to know more about what's really happening in the construction industry, and I found that all these large constructors and construction companies are very much interested in how to utilize this natural language-based technology to automate and to make it more efficient their construction management processes. So knowledge graph, sort of a new form of database, and largely the availability of new technology called generative AI and NLP-based solution. Combined, I realized that I could use it, or we could use it, for solving some automation and digitalization problems in construction. So from this slide and for several slides on, I'll be introducing you what kind of efforts that I have invested in this area. So the first research topic that I delved myself into was about modeling safety guidelines. When you go to KOSHA, Korean Occupational Safety and Health Association's 산업안전보건공단 in Korean, when you go to their site, there are about 90 PDFs uploaded. It's all separate PDFs, and each of the PDF has about 50 pages to 100 pages document. It all says, okay, what you should do in this circumstance, what you should do in this circumstance, what you shouldn't do in this circumstance. It's just like full description, all in text, and some pictures. Just saying what to do or what not to do. I'm not sure how many of you have read it, or anyone in the industry will be interested in reading that document in their spare time. So so the problem that I realize is there is a big separation and isolation between this kind of recommendation information available in text and how much it is being utilized in industry. The construction safety is a big issue in construction industry, probably more important than any other times in before, because of this new, law introduced just about last year, 중대재해처벌법 and all that. So my goal in this research project was how to digitalize this old safety guidelines information which exists in text, turned into some form of a more searchable, more computable form of database, which is, as I introduced, the knowledge graph. And then the end goal is a recommendation system. So since it is my current research effort, unfortunately, I still don't have the final form of recommendation system that I can introduce you today, because it's a 3-year project funded by NRF, Korean, National Research Fund Foundation. So I'm currently doing my 3rd year research. But I have very much lesson learned about how to model knowledge graphs. So that is actually one of the most important information and knowledge that I wanted to share in this seminar. So let me show you some more details. So this is the content, for example. For example, I'll just read the short one. 공사 단계별로 발생할 수 있는 낙하 위험에 대한 최초 위험성 평가를 실시하여 안전대책을 포함한 낙하 방지 방호 계획을 작성해야 한다. So there are hundreds and thousands of this kind of statements in that about 90 PDFs. No one wants to read it. And then when accidents actually occurs, what happens? The auditory organizations such as 국가 한국 국립안전 so I just forgot. Previously was a 시설안전공단 and the 국립안전관리원. And then they will actually have the responsibility and the auditory power. So when an accident occurs, what they do is they will visit your site and then check, okay, what went wrong? And then actually what they look up is this document. So this standard is not for no use. This standard is used for that kind of, as a golden rule. Like you are supposed to follow, you are supposed to read it, and you're supposed to follow these kind of guidelines. But as I said, how much do we really have time to read that and apply it? So recommendation system that I aim is, what if like we create a knowledge graph, which is all like nodes and links and relationships. And when I just search, okay, today I'm going to do some excavation work with this type of excavator machine, and then currently it's raining and that, just to enter some conditions. And then this AI machine will tell you, okay, you need to make sure these 5 things, or you need to check out these 10 regulations from the guidelines, right? That's my end goal. So I had to create this kind of a knowledge graph. So at the end of the creation of that knowledge graph transformation, from that about 90 PDFs, I ended up creating 44,023 nodes, and even more, edges is 95,000. So that each node contains something like some keywords, like scaffolding or excavation, or some specific type of safety measures, such as so for example, if I turn this into knowledge graph, 공사 단계, 낙하 위험, 위험성 평가, 안전대책, 낙하 방지, 방호 계획, all these keywords will turn into nodes, and all these verbs, 하여야 한다, like it can be translated into sort of a relationship. When you do that, you should do that. Things like that. So you may wonder, okay, how I end up creating this many nodes and this many edges. If you have to read one sentence by one sentence and then going through this 1,000 and 1,000 pages, you will quit your PhD or master's study if I ask that to my students. So I use the natural language processing for that purpose. So knowledge graph is great when it's created with a good quality. You can ask them, you can search, you can do many fun things in the knowledge graph. And at the end, as I said, I'm aiming to create a recommendation system, which is actually same idea as a YouTube recommendation system. Once you watch something and the YouTube will tells you, okay, you want to watch this too? So it creates a sort of a knowledge base, based on your watching history. So kind of similar idea. But so that's all good. If knowledge graph is created, it's a great thing. But how can we create it? So that was the big research problem that I had to handle. So it's a very technical thing, but basically the long story short, I used NLP. More specifically, I actually tried several different ways. When you use natural language processing, you could create your own AI algorithm, and you can create own data generative AI. And then you can fine-tune existing large language models, because not GPT anymore, because GPT was an open API source, but not anymore from GPT-4. But you can still use a GPT-3 and an older versions, and you can use it for fine-tuning. And there are many other LLMs, which is an open source. So you can actually download it. The way that I explain it is those other LLMs are they have been trained with all this many billions of web pages, but not really construction specific documents a lot. So if you just ask some questions to the LLM, they will answer something funny, because they might not really understand the construction specific language or terminologies. So the metaphor that I use is those general purpose LLMs, probably you can think it as a person who has finished all the training with all the elementary school level training. So let's say it's a great, very smart 6th grade elementary school student who read 1,000 books. But if you ask something about construction, specifically about construction safety management, and the little, a boy or a girl will say, I don't know, or just to say something nonsense, right? But this person is greatly smart. So what you can ask them is, you just give this book and then say, okay, read it quickly, and then answer my quizzes. Since this person is very smart, this person will just read it in just a few minutes and then be able to answer my questions. That's the idea of RAG, which is largely about how to use LLMs for retrieval. So point that I'm trying to make is there are many different ways that you can use generative AI for this kind of a translation test. When you think about it, it's essentially translation from English to Korean, from another language, but essentially translating the text into knowledge graph is actually a translation problem. So there are many different methods. So you can create your own AI, or you could use GPT. You just pay ChatGPT and you can ask them to turn it into a knowledge graph. They can actually do that. Or you can use that kind of RAG technique to create knowledge graphs. So I cannot really have a time to go into all the details, but the point that I'm trying to make is just that there are many different ways that you can use LLMs to turn text into knowledge graph. So this is what I tried. So probably many of you have heard about the concept of prompt engineering. Prompt engineering is the thing that I just explained. So general purpose AI have not been trained for any construction specific information, but it has a great ability to learn really, really, really quickly. You can just throw some document in GPT-4, you just throw a document, just throw a PDF or throw some words. We can, have many, so you can actually input a very long document. Just throw that into GPT and say, you read it and answer my question. For a person, even if a very smart person, the person has to take at least several hours. But for GPT, ChatGPT, like GPT-4, for example, it takes just like 30 seconds to read it. So that's the idea of a prompt engineering. So there are these many PDFs. We designed some prompts to make it very efficiently the OpenAI's GPT 3.5, and then later we also tried the GPT-4 model. Basically read all these documents, and then we create this QA data set, like, okay, question and answer. So essentially what we did with this AI method is we prompt engineered, and then we basically upload this document, and then we ask OpenAI's GPT 3.5 create a QA data set for like 100 questions or 200 questions. You can do that. And then the question and answer is very reasonable. We checked that. The researchers realized that all these question and answers make a lot of sense. So this is many different kinds of LLMs. And then what we tried was we tried to fine-tune the LLM called Co-Alpaca. That was a Korean language, one of the Korean language trained LLM. So not GPT, because the training GPT is too expensive. So we give up on that, but we realized that there are many other open source LLMs, and we wanted to just play with it and have some fun with it. So with that QA data set that we created with the help of the GPT, we fine-tuned the Co-Alpaca model. Of course, when you fine-tune the model, basically this Co-Alpaca model can better understand all these construction languages. So previously, before tuning, you ask this kind of question, okay, 그라우팅 믹서기 사용 전에 어떤 안전 조치를 해야 하나요? If you ask that, just to Co-Alpaca, it'll say very generic things. 그라우팅 믹서기란 이런 것을 말합니다. Like a very generic knowledge, not the specific answer that you are looking for. But after you train them with this kind of a data set, and then it is fine-tuned, literally. 한국말로 미세 조정된다고 하죠. 그러면 내가 원하는 답을 이제 시작하게 됩니다. So using that technique, so as I said, GPT-4 presentation model, fine-tuned model, and RAG. What we did was, for this question, which kind of a natural language-based technique will give the best answer? We tested that. And probably it may not be very clear which answer is the best. So we wanted to use some quantitative measures. As I said, it's essentially translation problem as we understood. So all this BERT similarity, OpenAI similarity, blue diagram, Rouge F1 and Rouge sum F1, they are all different kind of metrics that have been developed by computer scientists to measure how good quality translation has been performed. Since we see this as a translation problem from text to graph knowledge, we use these measures. And then the current result is with a little bit of a margin, RAG showed the best performance, especially when we apply this Rouge score. But we still have to understand, because for some metrics, for example, for this one, GPT-4 and GPT-4 presentation performs the best, and fine-tuned model performs worst. But some other measures, such as a blue diagram, fine-tuned model shows the best performance and all that. So we still have to understand why different metrics of this transformation, of this translation performance is measured differently. So that's my current effort. Another knowledge base that we wanted to create is previously what I showed was translation of a safety management guidelines into knowledge graph. But another research efforts that I'm currently working on is how the accident database, all many thousands of accident cases, when you go to CSI incident information database, you can actually, you might realize, oh, that much information is being collected by Korean government. Whenever there is a construction accident or any other accident in any other industry, they will record so many things, the date and what happened, and then what was the type of accident, what was the environment, and some pictures. A lot of data is contained there. But again, what's the type of database? All very relational database. So you can actually download it, and then download it and you can open it in Excel. You will see that probably about 30 columns and all many rows for each accident cases. So what you can do, you can do some keyword search because Microsoft Excel provides you with that function. So you can say, okay, I'm interested in finding accident cases about some scaffolding work, 비계 work. You can say 비계 and then enter, and then it will give you like 100 cases. You still have to read it. You still have to use your own reading and use your own brain to really go through that many cases. But my purpose is, again, turn this database into knowledge graph database so that we can use some graph-based data science technology and all the other AI-based technologies. Again, the idea is a recommendation system. So how we can turn this relational database information into a knowledge graph and then create a recommendation system. So for example, you just search, okay, I'm going to do this work and use this machine and raining and then how many workers and some other conditions. And then all these relationships can be analyzed based on this graph knowledge base and say, oh, do you know that in 2021, March, there was this accident doing a very similar job in a very similar environment. And check this out. You want to make sure that this kind of accident will not occur in your site. So that's the type of recommendation that I want to create with this technique. So my students are turning into programmers, and then they have a lot of fun with the different types of models. And do you know when ChatGPT came out into the world? It's just about 18 months ago. I mean, you might feel that, oh, it's forever around, but it's actually early 2023 that we started to use the ChatGPT. This area, this field of research and this world is changing so fastly, so quickly. So every other month, there is going to be a new LLM. And then famously, Google announced their own large language model based service called Gemini. So it was just about a couple months ago, and then they opened it as an open source. So my students just started to say, oh, okay, let's just put GPT aside, and we want to have some fun with the Gemini for this month. And I said, okay. So for this particular task, they were using Gemini, and then this is the type of information contained in CSI, like 사고 경위, 사고 종류, 사고 당시 작업, 사고 당시 환경. There are many more. It's just a kind of a capture of the main information that we were looking at. So again, we can, for example, like this kind of simple information, we can just create as a node. 낙하물 사고, it's just one node. But for 사고 경위, this is a description. So we use the same technique. Use the LLM, 분전함 개방, 야적, 판넬, 하중, 판넬의 맞음. Like such keywords are extracted using those AI-based technique. And those turn into the separate nodes. So that way, if there were like 1,000 accident cases, probably the number of nodes in my graph knowledge database will be like 10 times more than that because of that kind of extraction of all the keywords and then turn them into nodes. So all these relationships, such as, okay, this is the 사고 종류, like the type of accident, this was like what they were doing, and then all this like environment in which they perform the job, that kind of things can be modeled as a relationship, right? So once that is done, that's the look of the database, and then you can search. We call them like knowledge search. Probably many of you have used the neighbor's 지식 검색, and then who answers the question, experts. But what we want to create is some sort of AI expert. So based on all this knowledge contained in CSI or contained in any other guidelines, they can ask specific questions about knowledge, and then computer system can answer. So yeah, for example, like the type of question that we'll be asking is, in this circumstance, in this machine, we'll doing this construction task, and then what should I look out for? 내가 뭐 조심해야 돼? 물어보면 다 알려주는 그런 we were trying to create that kind of retrieval machine. I'm mindful of the time given, so I'll just move quickly because the rest of the story is very similar. So when they realized, my colleagues in KICT, 건설기술연구원, found out that I'm doing this kind of research, they said, oh, there are these many books like 건설빔, 시행지침, 발주자편, 시공자편, 설계자편, and they also making 적용지침, all these many public agents like 도로공사, 철도공사, 공항공사, LH, and all these different public project owners, they are publishing their own guidelines on top of these guidelines published by the government ministry. So it just only increase how many books they should read. If you're a designer, if you are a designer, or if you're a constructor, you want to follow the guideline. But then like that many thousand pages. So we are again using the same technique. We're translating these big guidelines into knowledge graph. So therefore, if you're a designer, you just want to use this knowledge graph, asking, okay, I'm the designing this type of facility according to the BIM guidelines. What should I submit? And we have developed some little program. So based on this knowledge graph, basically, if you're a designer, if you work for some 설계사, and I say, okay, there is this 도로공사 road construction project, and then I'm creating BIM project, and what should I submit? And then the Excel, this program we deliver to the KICT will create a small list. Okay, if you're a designer, you have to submit these 21 items to the project owner according to the BIM guidelines. So we have deliver that little software to KICT. So yeah, I'm almost wrapping up this presentation. So which direction do I think this type of research will move forward? So far, I have talked largely about just the text translation specifically into knowledge graph. But I think a more and more increased modality can get involved in this database. Still, I'm talking about graph database, because the graph database I have created so far, it all consists of all this statements and words and relationships, also text. But then, like, what about like some pictures of some particular construction site condition, or some images, or some sound? That kind of different types of data can also be integrated into this graph database, right? Not just the text, not just textual information. So I think, and I strongly believe that database design will become more and more inclusive of other types of model data. So how LLMs will evolve to include other types of data, that's probably not some kind of research topic that we can address, because we're not really computer scientists. We have a limited, knowledge and technology and techniques in that. But as soon as computer scientists develop or publish their own LLMs, having greater modality, like including images and all that, I think there is a great opportunities, not just the CSI database or not just the construction safety guideline documents, but what about some accident images or some even videos that can all be linked with that kind of relationships, and then the recommendation system not only just to provide you with a list of the things to do, but also it can create some pictures. Okay, you make sure like this kind of a picture you have to look at before you go into the job today, something like that. So I believe that that's the near future research direction of my type of research, or any other types of LLM or AI, generative AI based research regarding knowledge graph. So that's the last slide of my presentation, and I'd like to acknowledge my research has been supported by NRF and KICT, and that's it. So I'll welcome your questions. Thank you very much for your attention.
We have questions, and thank you very much for your very informative and inspiring lecture. It's a real pity that we do not have enough time to discuss all the details of what we presented. So I'd like to have questions from floor. You may go on.
박사과정 이유진입니다. 좋은 세미나 먼저 감사드리고요. 제가 하나 질문 드리고 싶은 게 제가 잘 몰라서 이제 말씀해주신 부분 중에서 이제 일단은 이런 식으로 모델이 구성이 되면 신뢰성을 검증하게 되는데 그럼 신뢰성을 검증을 할 당시에 이제 제가 이해를 하기로는 이제 주관적인 그런 부분들이 좀 있을 것 같아서 그럼 그런 것들 동량적으로 비교 분석할 수 있는 그런 지표가 있을까 해가지고 한번 여쭤보고 싶습니다.
아주 좋은 질문입니다. 여기에 대해서 뭐 제가 정답을 말씀드릴 수는 없고 오늘 아까 서두에 말씀드린 것처럼 제 current research effort를 소개해드리고 쉐어하는 그런 데 중점을 뒀기 때문에 마찬가지로 제가 지금 하고 있는 연구 위주로 말씀드리겠습니다. 일단 제 연구실에서는 아까 말씀드렸던 여러 가지 그 번역에 관련된 정량 지표를 확인했는데 아까 박사과정 연구원께서 말씀하신 그런 정성적인 어떤 효과성, 유효성에 대한 검증은 결국에는 사용자를 인볼브해서 해야 되지 않나라는 그런 생각을 했고 저랑 요 연구에서 제가 연세대학교 김홍조 교수님이랑도 좀 같이 계속 협업하고 있는데 최근에 저희가 이제 서브미트한 페이퍼가 뭐냐면 과연 이 여러 가지 GPT나 파인 튠 모델이나 RAG나 여러 가지 LLM을 갖고 할 수 있는 여러 가지 다양한 테크닉들로 나온 앤서들이 과연 사용자에게는 어떻게 느껴지는가. 사용자의 사용성, 우리가 뭐 그거를 유저빌리티라는 표현으로 묶을 수도 있을 테고 또는 뭐 어떤 밸리디티라는 표현으로 묶을 수도 있을 텐데 그거를 저희가 카테고리를 나눠봤습니다. 얼마나 답변이 컴플리트한지 그리고 얼마나 답변이 relevant한지 상황에 맞는 답변인지 그리고 또 correct, 당연히 correct해야죠. 건설 기준이든 뭐 안전 기준이든 또는 뭐 설계 기준이든 틀린 정보가 오면 안 돼서 얼마나 정확한 숫자와 정확한 정보를 줬는지 그런 식으로 저희가 카테고리를 전부 총 5개의 카테고리를 만들어가지고 그걸로 설문지를 만들어서 이제 테스트를 해본 그런 연구도 있습니다. 그래서 지금 저의 생각은 결국에 이런 디지털라이제이션 연구는 정량적으로 평가될 수 있는 영역이 있고 결국에는 사람이 인볼브 돼야지만 평가할 수 있는 영역이 여전히 존재한다. 여러분들 아실지 모르겠지만 GPT 3.5랑 GPT 4 사이에 굉장히 품질이 달라졌다고 여러분들이 느끼신다면 거기에는 결국에 오픈 AI가 시도한 사람에 대한 피드백. 여러분들 보시면 3.5나 4 이용하시면 답을 2개를 주고 어떤 대답이 더 좋으셨나요를 가끔 물어봅니다. 그래서 그게 뭐냐면 오픈 AI에서 계속 사람의 피드백을 구하는 거예요. 그래서 전에보다 더 안정성이 많이 있다라고 느끼는 바 그런 것들이 결국에 오픈 AI 3.5는 오픈 AI 3까지 헐루시네이션 프로블럼이 되게 많아요. 그러니까 오픈 AI 3까지는 우리 그 컴퓨터 사이언티스트들이나 이거 이용해본 사람이 뭐라고 하냐면 수천 권의 책을 읽은 어린아이와 같다. 그러니까 막 자기가 떠드는데 무슨 말을 하는지 모르는 겁니다. 맞고 틀린지 모르고 그냥 머릿속에 떠오르는 걸 계속 말하는 겁니다. 근데 말하는 건데 들으면 맞는 말 같이 다 들리는 겁니다. 근데 사실 알고 보면 틀리고 뭐 이런 것들이 문제가 굉장히 많았는데 3.5, 4를 거치면서 그런 것들을 많이 제어하기 시작했고 특히 4에 오면서 제일 오픈 AI에서 강조했다고 알려져 있는 게 오픈 AI는 3.5 이후부터 논문을 발표하지 않고 있습니다. 과연 어떤 알고리즘으로 이렇게 더 좋은 성능을 내고 있는지 공개를 하지 않고 있어요. 근데 지금 알려진 바로는 사용자 피드백을 결국에는 많이 감안했다. 그렇게 정성적 평가, 결국에 디지털라이즈된 정보로 어떤 서비스를 제공했을 때 결국에는 사용자 단에서 이거 진짜 맞는 정보고 전문가가 체크해보니까 다 맞네. 그리고 내가 딱 필요한 정보를 줬네. 그리고 내가 원하는 맥락에 맞는 정보를 줬네. 라는 그런 사용자 중심의 측정이 결국에는 이루어질 수밖에 없지 않나라고 생각을 하고 관련 연구를 진행하고 있습니다. 네.
저는 박사과정 이승현 학생입니다. 저도 사실상 비슷한 질문을 했는데 아까 퍼포먼스 메저스를 표로 만들어 주셨는데 그러면 이거는 비슷한 방향성이라고 아마 생각이
네네.
그리고 노드 종류들에서 카테고리 노드랑 컨텐츠 노드, 인덱스 노드에
네네네.
대해서 그게 어떤 차이점이 있는지.
아, 네네. 그거는 이제 지식 그래프도 데이터베이스이기 때문에 이 디자이너의 아이디어가 들어갑니다. 여기서 말하는 디자인은 이 그래프 데이터베이스를 디자인하는 사람. 그래서 데이터베이스의 디자인은 스키마라는 표현으로 보통 부르거든요. 그러니까 아까 말한 관계형 데이터베이스도 내가 어떤 칼럼들을 만들겠다, 어떤 식으로 롤을 구성하겠다는 게 이제 아이디어가 들어간 거잖아요. 그러니까 똑같은 어떤 시스템을 만들고 싶어도 데이터베이스 디자이너에 따라서 약간 다른 열과 행을 구성할 수 있는 거예요. 그래서 저희가 구성한 거는 지금 거기서 컨텐츠는 아까 말씀드린 그러니까 저희가 지금 그렇게 번역 작업 비슷하게 해서 그래프 날리지로 만들려고 하는 게 그런 지침 문서였으니까 거기에 보면은 다행히도 빔 지침도 그렇고 안전 지침도 그렇게 이렇게 분절된 하나의 선언문식으로 우리가 구분할 수 있는 하나의 스테이트먼트라고 부를 수 있는 단위가 있습니다. 때로는 두세 문장이고 어쩔 때 한 문장이고요. 그래서 그걸 하나의 컨텐츠라고 부르고 그 다음에 아까 말씀드린 거기에서 키워드를 뽑아낼 수 있다고 그랬잖아요. 그걸 우리가 인덱스라고 뭐 키워드라고 불러도 될 테고 그런 식으로 다른 종류의 정보들 위계가 다르다고 보시면 되겠습니다. 그래서 거기서의 관계는 include 관계로 그러니까 이 스테이트먼트는 이 인덱스를 포함하고 있다 이런 식으로 그러면은 A 스테이트먼트랑 B 스테이트먼트는 얼마나 비슷하냐 이 인덱스의 겹침 정도 similarity 스코어를 뽑아서 이 인덱스랑 이 인덱스는 얼마나 서로 연관이 깊다 이런 것들도 우리가 정량적으로 다 링크의 강도를 만들어낼 수 있거든요. 그러니까 그런 것들이 왜 가능하냐 결국에 그냥 텍스트로 돼 있으면 그냥 쭉 줄글로 돼 있던 걸 어떤 식으로든 그래프화 시키니까 그런 식으로 이 노드랑 이 노드랑 얼마나 비슷하지? 그러면은 여기에서 인덱스가 다 4개 있고 여기서 인덱스가 5개 뽑혔는데 이 중에 3개가 겹친다. 그러면 이 스테이트먼트랑 이 스테이트먼트 관련성이 되게 높은 거네. 그런 식으로 우리가 클러스터를 만들 수도 있고 어떤 유사성을 체크할 수도 있고 지침을 우리가 지도로 묶을 수도 있거든요. 여기 이런 덩어리들 이런 식으로 묶을 수도 있고 여기는 그래프 데이터베이스 사이언스라는 또 이제 그런 어떤 테크닉 영역 이제 한번 그래프 형태로 이제 디자인이 되고 나면 거기서는 우리가 다양한 걸 시도해 볼 수 있습니다. 그 중에 저희가 시도해 본 거는 아까 말씀드린 클러스터링, 이렇게 묶는 거. 그다음에 유사성 체크를 해가지고 이제 비슷한 정보가 뭐가 있는지 관계성을 중심으로 예를 들면 그 recommendation 시스템 아까 말씀드렸을 때 여러분들 recommendation 시스템 굉장히 정교하게 설계돼 있어요 유튜브에서. 그러면 희한하게 내 마음을 읽듯이 내가 관련된 거 많이 보여주셨나요? 근데 가장 기본적으로 유튜브의 recommendation 시스템은 similarity입니다. 이 비디오와 이 비디오의 등장인물, 어떤 퍼블리셔가 했는지, 언제 나왔는지, 주제 키워드가 뭔지를 쭉 나열한 다음에 그 인덱스를 비교해서 얼마나 겹치는지를 바탕으로 이것도 보고 싶지 않아? 근데 이것도 문제는 있습니다. 그러니까 계속 비슷한 내용의 유튜브만 계속 recommended해서 오히려 너무 그렇게 되긴 하는데 일단 제가 아까 말씀드린 대로 오늘 하려는 작업, 오늘 환경, 날씨, 그리고 어떤 컨디션 그런 것들을 입력했을 때 그것과 가장 유사한 지침 사항을 뽑아주는 거는 recommendation 시스템으로 충분히 의미가 있다. 그런 생각으로 일단 접근을 하고 있습니다. 아까 노드의 질문을 자다가 좀 제가 답을 좀 더 넓게 했는데 하여튼 노드는 스테이트먼트 노드는 그런 거, 인덱스는 거기서 뽑아낸 키워드 뭐 이런 식으로 위계로 구성되어 있다고 보시면 되겠습니다.
네, 감사합니다.
네네.
Just one sir.
Sure.
So I have two questions. The first one is in this case the AI get the input information like just safety standard. They will give some recommendation what should do or not to do or give some example from the past. My question is the answer of the AI is like quite narrow and specifically. So what my question is like what is the idea that you use to make the AI improve their answer?
Improve.
And like just not just like okay, in this case you do this or not to do this, but you say that in your presentation the AI have to improve their answer like more specifically or give some very detailed information like that. What is the idea that you use to train that AI? So that is the first question. The second question is, in this case, do you have to consider about the overtrained AI?
You mean like a overfit problem?
Overfit problem.
Overfit
Like
problem.
sometimes like
Yes.
we train it
Yes.
a lot
Yeah,
too
yeah,
much.
yes.
So if you get some,
Yes.
yes,
I get it.
this is
Okay, the first part, my short answer is we don't really consider improvement algorithm because there are different types of AI, and then there are some that famous generative AI, and then what we are trying to achieve is what they call retrieval AI. So retrieval AI and generative AI is a slightly different purpose. Generative AI is generating something new. So you have to check the relevance, you want to improve it further and further, but retrieval is largely about getting the right information and bring it to you. So we want to check, rather than the word improvement, we want to check the relevance and clarity and correctness and of that kind of retrieve the information. So it's largely about search. When you do some search, you want to get the correct and relevant information. So what you have done so far in Google, you search with some keywords, you have to go through the long list to find the most relevant, most correct, the thing that you want. But what I mean by recommendation system is just create a list, presumably the most useful, most relevant, and most clear and correct information to you. So I don't know how to answer the question about improvement, but it's more about all the performance of that retrieval. Okay, so that's my answer for the first part. And second part, your question was about
overtraining.
Yeah, overtraining. So that's a good question, because when you train any AI model with a specific set of a document, it's actually quite obvious why that AI will give you a better answer, because it has been trained with that specific type of words and terminologies and all that. So overfitting may be a problem, but we have not seen the overfitting problem yet, because at the end of the day, overfitting problem can be tested as that kind of a metric. So when you train the data with this data set and then test it with another data set, and then when there is an overfitting problem, that kind of a quantitative metric will pick it up. Because when overfitting happens, what happens? It has a great fit with the training data, and then when you test it with the test data, it doesn't give you that good fit. So essentially, the overfitting problem will be clear when you test it with the two different data sets. So we check that, but we haven't seen too much of overfitting problem. But we are actually concerned more about underfitting problem, because the general purpose AI, Gemini or ChatGPT, before they are trained, they don't perform well. Like when you ask specific questions of how to manage construction safety, their answer is everywhere. But when you actually train with some set document as we give, and then just performance only increases, and we haven't seen too much concerns created possibly because of overfitting problem yet. But that's a good question. We haven't really tested for that exact purpose, but I would say I have not observed any evidence for the overfitting problem with my data set and with my training algorithm yet.
Thank you very much for your answer.
우선 전 박사과정 장식으로 굉장히 좋은 세미나 감사합니다. 아까 이승현 학생 질문에 좀 연장선인데 인덱스로 릴레이션십을 체결한다고 하셨는데
네.
그 인덱스의 종류가 단어로 구성하는 건지 아니면 문장으로 구성하는지
네.
아니면 둘 다 되는 건지
일단은 인덱스라고 한 거는 제가 specifically 그 키워드를 뜻하는 용어로 저희 쓰고 있다고 말씀드렸고요. 그러니까 스테이트먼트에서 인덱스를 쭉 뽑아내는 기존에 존재하는 ChatGPT가 될 수도 있고 다른 NLP 알고리즘을 통해서 거기서 이제 키워드를 뽑아낸 걸 우리가 인덱스 노드라고 부르는 것이고, 그것들을 가지고 스테이트먼트 사이 간의 유사성이나 이런 관계를 파악하고 있다, 그런 뜻입니다. 그래서 그 관련돼서 이제 실제 제가 구체적인 방법은 아까 지 교수님 말씀하셨지만 시간이 없어서 방법적인 부분은 저희가 많이 소개를 못 해드렸는데, 그 방법도 여러 가지가 있습니다. 그냥 기존에 아주 벌써 한 15년 전에 개발된 그런 인덱스 뽑아내는 방식도 있고요. 그다음에 실제 지금 여러분들이 문장을 하나 주고 챗GPT한테 이거를 RDF 구문으로 만들어줘. 그럼 뭐냐면 주어, 주어, 동사, 그러니까 주어, 수어, 그리고 그 안에서 그 관계, 이런 식으로 뽑아줘라고 하면은 그렇게까지 뽑아줍니다. 그러니까 그런 용어까지 이해하거든요. 그러니까 키워드로 뽑을 수도 있고 그런 식으로 어떤 문장 하나를 주고 주어, 수로, 그 다음에 그거의 관계 이런 식으로 이렇게 A, B, C, RDF에서는 항상 그렇게 세 가지 엘리먼트가 존재하거든요. 그러니까 모든 문장으로 존재하는 정보를 다 그러니까 뭐로 출발해서 뭐로 끝나는데 그 관계는 무엇이다. 이걸 RDF 구문이라고 하는데 그 형태로 뽑아줘라고 하면은 챗GPT가 그렇게 뽑아주기도 합니다. 그래서 처음에 3년 전에, 2년 반 전에 이 연구를 시작할 때는 좀 전통적인 정량적 방법을 썼었고 그 뒤에는 점점 더 저희 연구실에서는 그런 AI 이미 우리가 액세스할 수 있는 제너레이티브 AI 서비스를 이용해가지고 키워드도 뽑고 RDF 구문 형태로 뽑고 싶으면 그렇게도 뽑고 그러니까 수많은 수천 장의 PDF 다큐멘트를 저희가 일일이 한 줄 한 줄 읽으면서 온톨로지를 작성하는 것은 거의 불가능한 일이라고 생각을 하고 어떻게 하면 이걸 자동화할 수 있을까? 자동화하는 데 있어서 방법으로서 그러니까 이런 데이터를 중간에 추출해내는 방법론으로도 또 AI를 쓰고 있는 겁니다. 그러니까 AI가 전체 제가 개발하려고 하는 시스템 또는 어떤 연구 방향성 지향점 자체이기도 하면서 중간중간에 연구 방법으로서도 또 AI를 쓰고 있습니다. 중간에 어떤 이런 정보 추출해줘요. 그런 것도 일일이 사람이 하려면 너무 오래 걸리니까 그런데도 굉장히 좋은 퍼포먼스를 저희가 확인하고 연구 방법론 자체로 쓰고 있다. 그래서 그 관련돼서 제가 작성하고 있는 논문이 있는데 그러니까 AI as a construction informatics research method 이런 식으로 그러니까 목적으로서만 우리가 많이 언급하잖아요. 이거를 AI로 구현했다. 이걸 AI로 이렇게 디텍트하게 만들었다. 이런 식으로 목적이 되는 경우가 많은데 사실 AI가 굉장히 좋은 도구잖아요. 그러니까 이걸 가지고 연구하는 방법으로서 제가 아까 말씀드린 키워드를 뽑는다든지 RDF 구문을 뽑는다든지 그런 온톨로지 작성 자체도 여러분들이 혹시 관심 있으시면 시켜보시면은 이미 텍스트를 그런 어떤 온톨로지 형태로 뽑는 그런 역할도 이미 사실은 굉장히 잘하는 성능을 가지고 있다. 그런 것도 좀 팁으로 말씀드립니다. 저희 연구실에서 계속 트라이얼 하면서 이제 그거를 실제 아까 보여드린 시스템을 구현하는 데 많이 사용하고 있었어요. 그런 자세한 연구 방법이나 프로세스적인 측면은 제가 시간 관계상 많이 소개를 못 드렸습니다. 대답이 됐나요?
네, 교수님 설명 감사합니다. 김한배 학생입니다.
네.
다름이 아니라 제가 이해하기로는 결국에 교수님이 하시는 연구 중에 AI 부분을 그냥 블랙박스로 두고
네.
원하는 인포 파일들을 넣어서 AI를 학습시킨 다음에 원하는 대답을 얻기 위한 퀘스천을 던져서 원하는 대답이 잘 나오게끔 만드는 총 과정을 하고 있는 걸로 제가 이해를 했거든요. 혹시 이게 맞을까요?
그것도 아주 좋은 질문입니다. 근데 저는 지금 제가 하고 있는 연구를 컴퓨터 사이언스 쪽에서는 뭐라고 부르냐면 이게 심볼릭 뉴럴 컴퓨팅 뭐 이런 키워드로 검색하시면 저랑 비슷한 연구를 하는 컴퓨터 사이언티스트들이 많이 나올 겁니다. 심볼릭 뉴럴 컴퓨팅. 뉴럴 하면 뉴럴 네트워크가 떠오르시죠. 그리고 뉴럴 네트워크 하면 블랙박스가 떠오르고요. 그다음에 심볼릭 컴퓨팅이라는 거는 이제 기호주의와 연결주의로 나뉘는 AI에서 기홀주의는 이제 그런 심볼릭 AI가 있고 그런 이제 그런 연결식 그런 뉴럴 네트워크식 AI가 있습니다. 근데 아까 그 대답의 가장 숏 앤서는 이겁니다. 연구 방법에서는 블랙박스를 많이 사용하고 있습니다. 제가 아까 말씀드린 대로 RDF를 뽑아줘 라고 했을 때 이 문장을 정확하게 어떤 알고리즘으로 RDF를 뽑아주는지 그 알고리즘은 제가 큰 관심을 기울이지 않는 거죠. 그러니까 이거의 퍼포먼스만 그냥 보는 겁니다. 갠지 고양인지 잘 맞추는 걸 확인했으니 나는 사진 수천 장을 주고 넌 갠지 고양인지 맞춰서 나한테 알려줘. 내가 원하는 데이터셋을 만들기 위한 목적으로 블랙박스를 사용하고 있습니다. 근데 그렇게 해서 만든 지식 그래프는 화이트박스거든요. 그래서 이렇게 이해하시면 됩니다. 중간에 제가 그러니까 결과적으로 이 전체 리서치의 프레임워크가 되는 저의 AI 모델은 리커멘데이션 시스템의 가장 주된 틀은 화이트박스입니다. 왜냐하면 결과물로 만들어진 지식 그래프 자체는 제 이해로는 그거는 심볼릭 AI의 한 종류고 심볼릭 AI에서는 모든 그런 노드들, 관계들이 다 익스플리시트하게 정의되어 있거든요. 거기서 이제 리트리벌만 이루어집니다. 리트리벌이라고 하는 게 검색을 통한 정보의 전달만 이루어집니다. 이 과정은 화이트박스죠. 근데 이거를 제작하는 데 있어서 텍스트를 수천 장을 읽어서 거기서 뭔가 여기 이 난리지 그래프를 작성하기 위한 기초 데이터를 만드는 데는 제가 블랙박스를 이용하고 있다. 거기서는 그걸 어떻게 만드냐? 그건 이제 그런 AI 이미 나와 있는 서비스의 영역으로 저는 그냥 이용하는 거죠. 그래서 그 대신 이제 그거의 성능만 검증하는 거죠. 제가 뭐 100개를 뽑아보고 그게 이제 우리 인간 휴먼 리서치들이 보니까 굉장히 정확하게 뽑아주더라고요. 그럼 거기서부터는 이제 내가 PDF로 1000장을 주고 자 여기 각 문장을 전부 다 키워드로 뽑아줘. 이 각 문장이 전부 RDF 구문으로 만들어줘. 그런 다음에 그 기초 데이터로 저희가 지식 그래프를 구성하고 이걸로 리트리버 시스템을 만든다. 이런 컨셉으로 그러니까 화이트 박스랑 블랙 박스를 어떻게 혼용해서 쓰느냐가 저는 굉장히 제 연구에서 중요한 부분입니다. 그래서 그렇게 이해해 주시면 되겠고 관련된 연구도 찾아보시려면 그 심볼릭 뉴럴 컴퓨팅 그 키워드를 찾으시면은 저처럼 비슷하게 섞어 쓰는 겁니다. 어디까지는 블랙박스로 남겨두고 요만큼은 화이트박스로 쓰고 뭐 이런 식으로 그런 관련된 연구를 좀 보실 수 있습니다.
교수님의 그 집중점은 그 블랙박스가 제공한 이제 가공된 재료를 쉽게 검색하기 위한 이제 그래핑을 하는 데에 집중을 하고 계신 거죠.
맞습니다. 그렇게 하고 그 이후에 애플리케이션까지. 그러니까 그냥 작성하는 건 일단 1단계고요. 그렇게 작성해서 뭘 할 거냐. 그거는 지금 연구실에서 아직도 좀 익스플로어 하고 있는 부분입니다. 그래서 아까 리커멘데이션 시스템 말씀드렸는데 그게 일단 1차적인 목표고 1차적이면서도 가장 인투이티브한 목표입니다. 어떻게 하면 화이트 박스를 통해서 내가 원하는 정보를 가장 맞춤형으로 주느냐. 근데 왜 이 안전 관련된 거는 특히 지침 정보는 블랙박스가 되면 안 되냐면 사실은 답을 줬는데 얘가 왜 이렇게 답을 줬는지 모르면은 지침으로서 내가 받아들여서 사용하는데 굉장히 거부감이 있을 수 있다는 것이죠. 그게 아마 설계 기준도 마찬가지지 않을까 그런 생각을 해봅니다. 얘가 LLM이 다 읽은 다음에 수만 장의 설계 기준 데이터를 읽은 다음에 나한테 블랙박스로 나한테 당신은 뭐 빔을 설계할 때는 높이는 어떻게 해야 되고 철근은 몇 개가 들어가야 됩니다 라고 했는데 이 완전 블랙박스로 처리되면은 이 신뢰도가 이제 의심을 할 수 있잖아요. 근데 그런 측면에서 이제 나름의 제가 가지고 있는 인사이트는 건설 산업은 굉장히 표준과 기준이 중요한 산업이기 때문에 블랙박스로 쓸 수 있는 구간은 끊고 결국에 어느 정도 수준부터는 화이트박스로 만들어서 모두가 이 리즈닝 프로세스를 관찰할 수 있는 형태로 된 AI가 좀 더 신뢰할 수 있는 AI가 되지 않을까 그런 좀 컨셉추얼한 접근 방법을 저는 가지고 연구를 하고 있습니다.
아, 이해했습니다.
대답이 됐나요?
네. 근데 그러면 그래핑하는 과정 자체에서는 AI를 사용할 생각은 없나요?
그래핑 자체에 AI를 많이 사용하고 있는 겁니다. 그러니까 기초 데이터를 뽑아서
네.
거기서부터 그래프로 이렇게 트랜슬레이트 하는 과정은 굉장히 스트레이트포워드 하거든요. 거긴 좀 기계적인 과정입니다.
아, 그래요?
예, 그래서 아까 말씀드린 RDF를 뽑아서 노드 그리고 관계 이렇게 뽑으면은 그냥 파이썬 코드를 이용해서 이거를 그래프로 만들어 줘라고 하는 과정은 그냥 스트레이트포워드한 과정입니다.
아, 그럼 전문가가 필요한 능력은 그 만들어진 그래프로 어떻게 이제 받아들일 만한 건설 기준을 정리하는 건가요?
제가 봤을 때 지금 연구자로서 가장 우리가 관심 가질 수 있는 부분은 이 그래프 데이터베이스를 어떻게 디자인하느냐. 이 데이터베이스의 디자인 자체가 결국에 또 애플리케이션에 연결돼 있거든요. 그러니까 어떻게 보면 내가 원하는 만들고자 하는 앱이 뭐다. 그거를 만들기에 가장 유용한 정보를 잘 담고 있는 형태. 왜냐하면 내가 어떤 질문에 대답하는 걸 만들고 싶어. 근데 그 질문에 대답을 못하는 형태로 데이터베이스가 디자인이 될 수도 있거든요. 그럼 문제가 있는 거죠. 그러니까 그런 식으로 애플리케이션 단과 어베일러블한 데이터 사이를 서로 왔다 갔다 하면서 어떤 형태의 그래프 데이터베이스가 가장 효과적이고 효율적인 형태의 정보 컨테이너로서 작동할까. 그게 지금 현재 제가 가진 리서치 포커스 중에 제일 핵심이라고 보시면 되겠습니다. 그리고 앞으로 좀 더 그걸 가지고 뭘 할 수 있을까. 쪽도 리커멘데이션부터 시작해서 좀 더 확장해 나가려고 지금 좀 더 생각하고 있습니다.
근데 그 과정을 따라갈 수 없는 블랙박스에 넣어버리면 그 심리적 불안감이 드니까 그 과정은 어쩔 수 없이 이제 사람이 알 수 있는 과정으로 해야 되기 때문에 지금 포커싱을 하고 계신 거죠.
제가 그러면 시간이 허락하는 예를 하나만 들어드릴게요. 제가 그 KICT에서 일할 때 그쪽 관련된 연구원님들께서 지금 빔 입찰 제안서를 딱 주면은 거기서 이게 빔을 할 때 얼마나 난이도가 있는 거고 이걸 할 때 얼마나 어렵고 어떤 경우에 어떤 걸 해야 되는지 정확하게 뽑아줄 수 있는 그런 AI를 만들고 싶다. 그리고 거기서 협업하고 있는 거거든요. 근데 뭐 이건 난이도가 어떻고 이걸 할 때는 구체적으로 뭘 해야 되고 이런 거에 있어서 AI가 생성했다고 칩시다. 그 블랙박스로. 그랬을 때 이 현업에 있는 사람들이 이 블랙박스 시스템을 바탕으로 우리가 KICT에서 새로운 시스템을 런칭했다. 그랬을 때 과연 이걸 사람들이 잘 사용할까? 그리고 받아들일까에 대한 굉장한 걱정과 의구심이 있다. 그런 얘기 하시더라고요. 그래서 어떤 난이도가 몇 점이다. 뭐 10점짜리 난이도. 그러니까 이거는 굉장히 어려운 빔 기술을 요구하는 입찰 제안서다 라고 했을 때 오케이 10점이라고 내가 블랙박스가 10점 이거는 난이도 10점 이렇게 했는데 10점을 보고 왜 이게 10점인지 그리고 내가 도대체 뭘 하면 된다는 건지 그런 식의 어떤 리즈닝이 가능한 연역적 우리가 추론이 가능한 그런 방법이 좀 있으면 좋겠다 해서 지금 지식 그래프를 저희가 같이 보면서 어떻게 하면 이걸 활용해서 그러한 이제 모델을 만들까 그렇게 지금 그런 걸 가능하게 하는 날리지 베이스 그걸 지식 베이스라고 하거든요. 그러니까 그런 지식 베이스를 어떻게 설계해서 그거를 가능하게 할까를 지금 연구하고 있다 이렇게 보시면 되겠습니다. 설명이 됐나요?
Alright. So no more questions, right? Actually, it was, we got this point just by chance, actually. But we were playing tennis at the time, right? We were playing tennis.
Yes, I was at the court with you.
And then when we talked about our current research activities, he told me that he wanna join to Professor Chisoko's group regarding this digital transformation project. And then when I talked with him about what he's gonna do, I found that his direction of research would be very useful regarding the current job that we're doing. So we have little challenges regarding, for example, we have two separate groups. The first group is they identify all the workflow process based on their engineering expertise. But they do not consider the construction code. Actually, although they know the construction code very well, but they don't pay attention to the details of the construction code. They forget about that. They just follow what they are doing in their daily life. And then they told us the flow of their job. Actually, not directly. I mean, keys and time. And then taking their product, and we have to change all these terms just for ready for the implementation, for the digital transformation. That poses lots of questions. For example, although they cited construction code, but to activate, to execute the construction code, we have to look up some more construction code. That caused a lot of problems. And then I would like to, I was looking for an efficient way to check whether we find the right path. So although we are doing the job manually, and also if I can have a reference for that, and that would be very, very useful. I got the idea, that's why I wanted to do the lecture today. Thank you very much for your time. Okay?